Hey, what's up, everybody? Hopefully you guys are getting adjusted to the semester. Just wanted to do a quick update on chapter 17, which deals with the endocrine system. And what you're looking at right now, I'll zoom out here just for a moment. You are looking at a crude mind map. A mind map or concept mapping is a way to take a whole bunch of random information that seems very difficult to conceptualize in your mind and put it together in a way so that you can actually navigate through the material. This is not a new concept. This is a concept that people use all the time. And I am not making this up. So this is something that people use in theory. Or it's a theory that people use, excuse me. So I'm not going to harp on that too much, but what I really wanted to get into is the nuts and bolts of the endocrine system, which if you started studying that, you've come to realize, hey man, where's the anatomy at? Because there's not a whole lot to get into as far as the anatomy is concerned. It's a lot of biochemistry and cell biology, a whole bunch of chemistry, a bunch of chemicals. So what I wanted to do is I wanted to take some time out to start everything where this chapter really revolves. It doesn't matter what textbook you're using. Most textbooks, like 80% of the chapter does nothing but deal with hormones. So I wanted to put the hormones in the middle because that's what the entire chapter seems to revolve around. And then we can follow the map as we go along. So I'm going to go, I'm going to go clockwise, and I'm going to start with 12 o'clock, which goes to the hypothalamus. So the hypothalamus is one of the first structures that you get to learn about in the endocrine system. It produces actually two different hormones. It produces oxytocin and ADH. You'll notice that I have a line written out here about neurosecretory cells. Neurosecretory cells are specialized neurons that actually make hormones. And because it's a chemical, it can do that. It puts it into vesicles. The vesicles travel down the axon all the way to the synaptic knob. And then it releases those chemicals at the synaptic cleft. And then those chemicals, oxytocin and ADH, are then sent and stored in the posterior lobe of the pituitary gland. The posterior lobe then releases these hormones when needed. We have ADH, which targets the kidneys, and the kidneys then in turn decrease urine production. And oxytocin is released in both males and females, and when oxytocin is released in males, it targets the prostate, and when it's released in females, it targets the uterus. So if we back out of this, we also notice that the hypothalamus releases releasing hormones and inhibiting hormones. Releasing hormones stimulate targets to get them to release something that they make. So an example of a releasing hormone is thyroid releasing hormone. Thyroid releasing hormone has a nice little conversation with the pituitary gland, and it gets the pituitary gland to release thyroid stimulating hormone, which then stimulates the thyroid to produce its hormones like T3 and T4. And I noticed that it's not here on this side of the board. It's actually over here on this side of the board. And we'll talk about that in a moment. So inhibiting hormones do exactly what you think they would do. They inhibit things from happening. And so that's why it's called an inhibiting hormone. If we continue going around the clock, we'll see that this line goes out to pituitary gland. We can see there's an arrow there drawn from the pituitary gland to the posterior lobe, just letting you know that the pituitary gland is divided into two lobes, the posterior lobe and the anterior lobe. And the posterior lobe, we just talked about it, it releases ADH and oxytocin. Whereas the anterior lobe is not getting its hormones from somewhere else. It's not having to store it from somebody else. The anterior lobe contains normal endocrine cells that produce several different hormones, one of which is ACTH, which is adrenocorticotropic hormone. Anytime a name of a hormone has tropin in it, I always say that means that hormone has you tripping. So tropin is the same thing as saying, yo, it gets it tripping. So ACTH starts your adrenal cortex to be tripping, and it releases glucocorticoids, which those glucocorticoids, I have an arrow there, and I have no clue why the glucocorticoids has an arrow there. We're going to erase that because we don't need that there. We're going to be talking about glucocorticoids a little later on. So adrenal cortex, if you don't know what that is, the adrenal cortex is the outer portion of the adrenal gland. Think of a melon. Think of a watermelon or a honeydew melon or a cantaloupe melon, some type of melon. And you notice how it has a melon rind, the outer portion, the outer thick area, and then the inner portion, which is the melon pulp, or the meat of the melon, as some people say. Well, the cortex is the melon rind, and the medulla is the inner pulp that we all tend to eat. So the adrenal cortex is the outer portion of the adrenal gland, and those produce things like glucocorticoids. And that's because ACTH is released from the anterior lobe of the pituitary gland. Now, the anterior lobe is busy. It's producing all types of stuff. So not only does it produce ACTH, but it also produces growth hormone. Growth hormone has a lot of things that it targets. It targets most of the cells of your body. Specifically, it targets bone cells and muscle cells. It can lead to the increase of lipolysis, and it can also lead to the stimulation of your liver and glucolysis, which is why when you release lots of growth hormone when you're a kid, why you can eat everything and all that stuff you eat doesn't seem to, affect you one bit. But then when you're grown, all of a sudden the stuff that you used to be able to eat just seems to go straight to the spots on your body where you didn't want it to go. Part of that is because of yes, you say your metabolism, and that much is true, but more importantly, all the different chemicals and hormones specifically that are active in your childhood and the way that they change in their activity when you're older. Now, the more active you are, the more you may activate certain hormones like growth hormone. And so you're able to metabolize certain things in a certain way as compared to an adult who is living a very sedentary lifestyle, which, of course, this weekend I'm going to attempt to live a very sedentary lifestyle for part of it. But I'm going to be very active once I get my paintball gun fixed and really go out there and have some fun on the field. So, with growth hormone, if we have too little of it being produced, we can see dwarfism. Some of you guys have seen the TV show Little People, Big World, that dealing with dwarfism. It's a lack of production of GH, of growth hormone, during their development stage. Also, if we have too much GH being produced during the development stage, that can lead to gigantism. If we see too much GH being produced during their adult phase, that can lead to acromegaly. So we zoom back out, back to the anterior lobe. Look, we're still in the anterior lobe. We haven't left this thing yet. So many different hormones created by the anterior lobe. The anterior lobe also produces TSH, which is thyroid stimulating hormone. Remember what I said earlier. I said that your hypothalamus creates releasing hormones. And so that releasing hormone from the hypothalamus, TRH, thyroid releasing hormone, actually targets the anterior lobe of the pituitary gland, which then leads to the release of thyroid stimulating hormone, which then stimulates the thyroid gland. And if we skip over to the thyroid gland here, we can see that the thyroid gland then in turn creates several different hormones. It produces T3 and T4, and it produces calcitonin. T3 and T4 are hormones that we release simultaneously. These hormones work together, they have a very synergistic effect. They generally affect metabolism. That's the safe answer to any question to you about T3 and T4 as far as thyroid hormones are concerned. They get their names based on their molecular structure and how many ions are connected to their molecular structure. You typically release more T3 than T4. You require higher quantities of T3 than you do T4, but they have to be in a particular ratio. And if that ratio is off, then the effectiveness of these two hormones are greatly reduced. So We look down here, we can see that it affects metabolism, which metabolism is a fancy word for saying the sum total of all the chemical processes that happen inside of your cells. Some of the things that happen when T3 and T4 hit the streets, we see an increase in amino acid and glucose uptake. In other words, we stimulate the cells in your body to start absorbing more amino acids and glucose out of the bloodstream and start metabolizing it, using it. So you start burning energy. We see an increase in respiration enzymes in the mitochondria, which is a fancy way of saying, hey, we increase activity in aerobic respiration, aerobic metabolism, which basically produces more energy, which also a byproduct of producing energy in a cell is heat. So your body begins to warm up. Another hormone that we see produced by the thyroid gland is calcitonin. Calcitonin targets several different cells in the body, including bone cells, in order to reduce blood calcium levels. Calcitonin tones down blood calcium levels. If we go back to the anterior lobe, the anterior lobe still chucking out hormones, man. This is like playing a spade game against somebody who's trump tight, and they're just throwing out spades, man. And you're just sitting there like, man, is there any end to this dude's spades? So anterior lobe, we can see that it produces thyroid stimulating hormone. We follow this long line down here. It produces prolactin. Prolactin stimulates mammary cell growth. So the mammary cells and tissues in the breast of the female increase. Also, milk production is increased there. So prolactin stimulates the female to increase milk production. Then we have gonadotropins. Remember what I said about tropins? They got something tripping. So gonadotropins, the two types of gonadotropins that we focus on are FSH and LH. FSH is follicle stimulating hormone. LH is luteinizing hormone. These two hormones both target the gonads, whether you're talking about male or female, it doesn't matter. These guys, they target the gonads. And since we're going into the reproductive system after this chapter, I will talk about the unique relationship between the gonads, the gonadotropins of the anterior lobe and these hormones and the gonads of the male and female, because they do totally different things in the male and the female. So we come back to the hormones. We follow this line over. We're done with the anterior lobe. Say bye-bye to it. Good grief, the dude just took up like a quarter of the whole board. We come back to hormones in our center of our mind map, and we find out that we've got the parathyroid gland, the parathyroid glands, because they come in pairs. And we don't know why they always have to come in pairs. We don't know why you always have an even number of them, and we don't know why you can have two, or you can have 10, and that it doesn't matter. We all secrete the same concentrations of this stuff. But it produces parathyroid hormone, PTH, and PTH does the exact opposite of calcitonin. PTH increases calcium in the blood levels, while calcitonin decreases calcium blood levels. You can see them right beside one another, and you can see one arrow's going up, one arrow's going down. The way that I learned this and remember it is calcitonin tones down blood calcium levels. PTH picks calcium levels up. And that helped me remember these two hormones and the difference between the two. So we come over, there's a big long line running from hormones over here to adrenal glands. The adrenal glands are just like our friend that we were, well, actually, it is the friend that we were talking about. I haven't gotten to that other structure yet. I was about to jump the gun. But adrenal glands are the guys that we were talking about when we were way up here in the top corner. We were saying ACTH targets adrenal cortex to release glucocorticoids. We can come back over here to hormones. We can follow this line down here to adrenal glands. Adrenal glands have two layers to the major layers. There's the cortex and there's the medulla. The cortex is the outer layer. The medulla is the inner layer. The medulla only makes two things, epinephrine and norepinephrine. And if you don't know what that is the happy little potent cocktail that creates what we call adrenaline. So we can stimulate the medulla in the adrenal glands, and he will then in turn make epinephrine and norepinephrine for us. while over here, the cortex is broken into 3 different zones. There's zones like the zona fasciculata and the zona glomerularis. And so these zones, or zona, they produce different groups of hormones. They produce mineralocorticoids, glucocorticoids, and gonatocorticoids. Now, it depends on your instructor as to how they want you to learn about this. We can go into this in more detail in another video, but one of the primary mineralocorticoids that you definitely need to know in any of your classes is aldosterone. You'll notice the name says mineral corticoids. So mineral is referring to aldosterone's targeting of sodium in the kidneys. Glucocorticoids, gluco is referring to sugar. That's why one of the primary glucocorticoids that you make is cortisol, aka the stress hormone. Cortisol is what you release into your body when you have to work an extra hour at work, or you're staying up late at night to study for an exam. Gonatocorticoids, they create things like androgens. Androgens are male hormones. In women, androgens, they're male hormones, but they turn into estrogen in women. Gonatocorticoids, they really don't matter much in adult males or men who have gone through puberty. However, this is a big deal for like little boys and women who their bodies require an androgen. They require that male hormone. However, they don't have gonads that are producing testosterone. So that's how they get that chemical. Getting down to the short rows now, one of the other structures is the pancreas. The pancreas is really a double agent because the pancreas is not only producing hormones, but he is also producing enzymes that help you digest food. So when we get to the digestive system, we're going to talk about that with our other mind map. But the pancreas also has beta cells and alpha cells, and beta cells produce insulin and alpha cells produce glucagon. Insulin targets most of the cells of your body, and it tells those cells to open up channels to allow glucose to go inside of the cell so that the cell can use the glucose for all different types of purposes. Whereas glucagon says, nope, let's do the exact opposite. There's not enough glucose, not enough sugar in the bloodstream, so let's do what we have to do and target the cells we need to target to allow sugar into the bloodstream. And then last but not least is the pineal gland, who the pineal gland produces melatonin. And melatonin actually targets working on your sleep-wake cycle. So the